Hello, welcome back. In this next video, we are going to talk about how to solve a right triangle. So remember from the previous video that when we solve a right triangle, it means that we want to know the lengths or the measures of all three sides of the triangle, and we want to know the measures of all three angles inside the triangle. Now, we already know that one angle is 90 degrees. We already know that we have two side lengths. One is 15 and one is 20. So don't forget, when you know two lengths of a right triangle, we can use the Pythagorean theorem to find the length of the third. So I'll set this up for you. And then you can math that out later. I'll just tell you for right now that when we math that out, 225 plus 400 is 625. The square root of 625 is 25. So the length of segment CA is 25 units. Now what we need to do is we need to pick an acute angle to call. It doesn't matter what reference angle you choose. You can choose either reference angle C or reference angle A. It's totally up to you. I'm going to choose reference angle C. And from this, I'm going to label my hypotenuse. I'm going to label my adjacent side and my opposite side. When I'm finding an acute angle measure in a right triangle, I always like to go back to the information that's given in case I made a mathematical mistake with that remaining side. So, in this particular example, I am going to use the opposite side and the adjacent side. Which ratio compares the opposite side and the adjacent side? That's right, it's the tangent ratio. So, I would say the tangent of angle C is equal to the opposite side, which is 20, over the adjacent side, which is 15. And now, because I want to figure out angle measure, I have to use inverse trig. Remember, inverse trig finds the measure of the acute angles in a right triangle. So, this is now going to become the tan inverse of 20 over 15, and that's going to equal the measure of angle C. So let's use our calculator, and we'll do the second tangent of 20 over 15, 20 divided by 15, enter. And that gives us an answer of 53.1, so that means the measure of angle C is equal to 53.1 degrees. So, if this angle here is 53.1 degrees and this angle is 90 degrees, can't I just subtract 53.1 from 90 to get the measure of angle A? So you can see here how you really only have to use inverse trig once. Then, once you find the measure of one acute angle, you can subtract that measure from 90 degrees to find the other. Now, what if you wanted to find the measure of angle A first instead of the measure of angle C? Then this would be my adjacent side. This would be my opposite side. Not going to worry about the hypotenuse right now. We're still going to use the tangent ratio. It's just going to look a little different. The tangent of angle A is equal to the opposite side, which is 15, over the adjacent side, which is 20. Now, I would want to find the tan inverse of 15 over 20 to give me the measure of angle A. Hopefully, it'll turn out to be 36.9 degrees. Let's find out. Second tangent, 15 divided by 20. Hey, look at that, 36.869, which is approximately 36.9 degrees. And that is the measure of angle A. You can choose to use inverse trig for both of them if you want to, but of course you do not have to. And now we have found of the angle measures and all of the side lengths in our right triangle, so we have successfully solved the triangle. All right, our next example. We're going to go a little backwards with this one. So find the measure of each acute angle first, and then solve the right triangle. I'm actually going to start with example 8. So in example 8, I'm going to choose angle C as my reference angle. I know that I'm given the side opposite from angle C and the hypotenuse. This, of course, is your adjacent side. If I want to find the measure of angle C, what ratio can I use? I need to use the ratio that compares the opposite side and the hypotenuse. Good. That's the sine ratio. So I have the sine of angle C is equal to the opposite side divided by the hypotenuse. Now I'm looking for angle measure, and a lot of students will actually skip this first step and just write the second step, which is totally fine. And now my calculator, I want to do the sine inverse of 8 divided by 9.2. And that gives me approximately 60.4 degrees, which means the measure of angle C is equal to 60.4 degrees. And now that I have the measure of angle C, in order to find the measure of angle R, I can just do 90 minus 60.4. So 90 minus 60.4 gives me 29.6 degrees. And now the last piece of information that we need to find, this is 60.4 degrees. This is 29.6 degrees. The last piece that we need to find is we need to find the length of segment CP. And in order to do that, we can do the Pythagorean theorem. CP squared plus 8 squared equals 9.2 squared. CP squared plus 64 equals 84.64. Subtract 64 from both sides, and we get CP squared equals 20.64. Take the square root, and CP is approximately 4.5 units. And we have now solved our right triangle. Question 7 and question 9 are very similar to question 8, so you can use question 8 as a guide. And the last question I just want to draw your attention to is example number 10. Notice how example number 10 differs from example number 9. In example number 10, you are given the measure of one of the acute angles, and you only have the measure of one side length of the right triangle. So this type of example goes back to what we did previously with regular trig. We already know what this acute angle is. It's 61 degrees. If I wanted to find the measure of angle C, I would just do 90 minus 61. Right? 90 minus 61 is 29 degrees. The measure of angle C is 29 degrees. We have now found the acute angle measures. So, that being said, let's use angle A, or the 61 degrees, as our reference angle. We still have to label the hypotenuse, the adjacent, the opposite. And now you can choose whatever side you feel like solving for. Let's say you want to solve for the hypotenuse first. All right. What ratio compares the adjacent and the hypotenuse? Right, it's the cosine. The cosine of an angle equals the adjacent side divided by the hypotenuse. We have the angle measure here. The cosine of 61 degrees is equal to the adjacent over the hypotenuse. And now remember, we did that like funky math where we multiplied both sides by h and then we divided by the cosine. So we can say that h is equal to 21 divided by the cosine of 61 degrees. So on our calculator, 21 divided by the cosine of 61 gives us a hypotenuse of 43.3 units. This is actually the length of segment AC. So when you're given the acute angle measure, we're just going to use regular trig. When you're given two side lengths of the right triangle and you want to find the measure of an acute angle, we're going to use inverse trig. And of course, we have one more length that we need to find. We need to find the length of segment BC. So of course, we can use the Pythagorean theorem to help us with that. And that would look like 21 squared plus BC squared equals 43.3 squared. And of course, you can math that out. Let's just do that quickly. 21 squared is 441. 43.3 squared is 1874.89. Subtract 441. Let's take the square root. And hopefully we get a number smaller than 43, which we do. We get 37.9 units. And now we have successfully solved our right triangle. We found the measure of our last acute angle. We found the length of our hypotenuse using trig. And we found the length of our remaining side using the Pythagorean theorem. I hope that helps. That was kind of a long video. I'll do another video just kind of explaining another example. But if you're feeling good, you can go right on to the practice problems. Thanks so much.